A gentle swell of music rises, soft at first, then deepening, carrying a feeling of awe and mystery. Just 100 years ago, our view of the cosmos was astonishingly small. Human understanding of the universe was bound by the limits of imagination and the faint light of telescopes still in their infancy. To most astronomers of the early 20th century, the Milky Way was not just our home, it was the entirety of existence itself. Every star ever seen, every misty nebula, every faint smudge of light in the night sky was thought to belong to our galaxy. The notion that the universe might stretch beyond the Milky Way was unthinkable. Creation, they believed, had boundaries. But in 1928, that narrow view cracked wide open. Astronomer Edwin Hubble, studying faint smudges of light through the 100-inch Hooker telescope at Mount Wilson, noticed something astonishing. These nebulae weren't part of our galaxy at all. They were entire galaxies of their own, each one composed of billions of stars, lying far beyond the Milky Way. And more startling still, they were moving away from us. The universe was expanding. This single realization changed everything. Humanity was no longer confined to one lonely island in the dark. The cosmos was revealed as vast, restless, and filled with galaxies rushing away into the void. In one stroke, our place in creation was forever redefined. Decades later, in 1997, another Hubble, this time the Hubble Space Telescope, revealed an even deeper truth. By peering into the faintest regions of the cosmos, it found that the expansion of the universe wasn't slowing down as scientists had expected. It was speeding up. Some unknown energy, invisible and powerful, was driving galaxies apart faster and faster. Scientists named it dark energy, though the name tells us almost nothing about what it truly is. This discovery forced scientists to revise the age of the universe. From earlier estimates of around 12 billion years, it was pushed back to about 13.8 billion years. For decades, this figure became the standard, the cornerstone of cosmology. But the universe has never been easy to pin down. And today, with the launch of the James Webb Space Telescope, the most advanced astronomical instrument humanity has ever built, cracks are beginning to appear in that cornerstone once again. M92. A star cluster that shouldn't exist deep within the Milky Way lies a cluster of ancient stars, known as M92. It is one of the oldest stellar groups ever observed, a dense ball of suns packed tightly together, orbiting in the galactic halo. By all accounts, M92 should simply be another relic of the early universe. Yet when scientists calculated its age, they stumbled upon a puzzle. M92's stars appear to be as old as the universe itself, about 13.8 billion years. Some models even suggest they could be older. But how can a star cluster inside the universe be older than the universe that contains it? Stars form after the Big Bang, not before it. To investigate further, astronomers turned to powerful computational models. They generated over 20,000 synthetic star populations, simulating how such clusters should evolve over time. Again and again, the results placed M92 right at the edge of the universe's supposed beginning. The unsettling implication: perhaps our cosmic timeline is not as accurate as we thought. Perhaps the calendar of the universe has been misread. Galaxies too ancient, too large. Then came something even stranger. The James Webb Space Telescope looked deeper than any instrument before it, into light that has traveled across billions of years, carrying with it the story of creation itself. What it found left scientists reeling. Webb detected galaxies that existed a mere 300 million years after the Big Bang. And yet, these galaxies weren't small, primitive collections of stars. They appeared massive, complex, and mature, as though billions of years of evolution had been compressed into a fraction of the time. By current models, galaxies of that size should have taken eons to form. Their presence so early in cosmic history breaks the rules we thought were unshakable. Rethinking the age of the universe, these discoveries have led to bold, even radical, proposals. What if the universe is not 13.8 billion years old? What if its true age is closer to 26.7 billion years, nearly twice as old as the number written in our textbooks? This idea is controversial, but it stems from real observations. If galaxies appear older than the universe allows, then either our understanding of cosmic evolution is deeply flawed, or the universe itself is far older than we have believed. The Methuselah star, older than creation? The mystery deepens with a single star, HD 140,283, nicknamed the Methuselah star. Careful measurements suggest it is about 14.5 billion years old, almost a full billion years older than the universe itself, according to the Standard Model. How can a star outdate the universe? By the physics we know, it should be impossible. Stars are born after the Big Bang, not before it. And yet Methuselah shines defiantly in the sky, as if mocking our calculations. Some propose that its chemical composition and burn rate are unique, allowing it to survive longer than expected. Others wonder if the problem lies not in the star, but in our estimate of the universe's age. The Hubble tension, a cosmic disagreement. At the heart of these contradictions lies a simple number, the Hubble constant, which measures how fast the universe expands. When astronomers look at the early universe, studying the faint afterglow of the Big Bang, the cosmic microwave background, they get a value of about 68 kilometers per second per megaparsec. But when they measure the expansion using nearby stars and galaxies, the value jumps closer to 73. This discrepancy, known as the Hubble tension, has persisted for years. It's not just a mathematical quirk, it could be evidence that our entire model of the universe is missing something fundamental. Could dark energy itself be evolving over time, shifting its strength as the cosmos grows older? If so, then the history of expansion, and our measurement of the universe's age, must be rewritten from the ground up. Beyond the Big Bang, cycles, black holes, and multiverses, these puzzles have breathed new life into old ideas. Some scientists now consider the possibility of a cyclic universe, a cosmos with no true beginning or end. Instead of starting in a single Big Bang, the universe might undergo endless cycles of expansion and collapse, Big Bangs followed by big crunches, repeating forever. If true, then the galaxies Webb sees in the distant past might be remnants of a previous cycle, echoes from an older universe. Others point to the role of primordial black holes, dense objects thought to have formed in the earliest fractions of a second after the Big Bang. If they exist, they might have served as seeds, anchoring the rapid growth of galaxies long before our models say it was possible. And then there is the boldest idea of all, the multiverse. Perhaps our universe is just one thread in a far larger tapestry. Countless universes may exist, each with its own physics, its own histories, its own lifespans. If these universes occasionally overlap or influence one another, they could explain why we see galaxies and stars that seem too old, too vast, too evolved for our cosmos alone. Could the James Webb Telescope be giving us the first indirect glimpse of worlds beyond our own? The quantum frontier. Time itself under question, adding yet another layer of mystery is quantum physics, the strange rules that govern the tiniest scales of reality. In the quantum realm, time doesn't always behave as we expect. It can stretch, bend, or even appear to vanish. At the dawn of the universe, quantum fluctuations may have been so powerful that they sculpted the very structure of reality, influencing the birth of galaxies and even altering the flow of time itself. Around black holes, we already know that time slows and dilates. Could similar effects have shaped the first moments of creation? If time itself is unstable at the smallest scales, then our entire cosmic timeline may be more fragile, and more mysterious than we ever imagined. Standing at the edge of a cosmic revolution. Every new discovery from the James Webb Space Telescope pushes us closer to the limits of comprehension. Each image it sends back is more than just data, it is a challenge. A whisper from the universe, daring us to see further, to think deeper, to question what we thought was certain. So, what if the universe isn't 13.8 billion years old? What if it is 26.7 billion years old, or eternal, cycling endlessly through creation and destruction? What if our cosmos is not the whole story, but merely a fragment of a much larger multiversal epic? One thing remains clear. The James Webb Space Telescope is not just a machine. It is a time traveler, a cosmic storyteller, and perhaps humanity's most powerful tool for uncovering the truths of existence. With each discovery, we are reminded that science is not a fixed set of answers but an evolving journey. A journey that pushes us to dream bigger, reach further, and embrace the mysteries that still lie beyond. So we must ask ourselves, are we standing at the brink of a cosmic revolution? Or have we only just begun to glimpse the first pages of a story far larger than we ever imagined?